Hello everyone, this is going to be our second video under trigonometry. So in this lesson we'll be talking about general solutions for sine, cosine and tan functions. So before we start with that, I have to remind you of this property of circular functions. Circular functions, as the name suggests, it goes in a circle, it revolves in a circle. These can be named as circular functions, but also they come under the category of periodic functions. I think you're already familiar with the periodic functions from functions chapter. There we looked at piecewise functions and periodic functions, right? So under this we learn about sine function, cosine function and tan function. Sine function was defined as y coordinate divided by, this is OP. OP in this case is equal to 1 because we are looking at a unit circle. Cosine is defined as x coordinate divided by 1 and tan is defined as y coordinate divided by x. Okay, so let's say that f is a trigonometric functions which represent either sine, cosine or tangent, right? Since I don't want to write this down for all the three functions, I will take f in general. So this circular function has this property. Since they are defined by their coordinates of the position, the function, say sine of theta, this function will give you a ratio as an output. This ratio is the ratio of coordinates as defined. So f theta is also equal to, since f theta depends on the coordinate, this will also equal to the coordinate when this OP1 line is revolved by 2 pi degrees. Let's say you revolve this, let me take another, this OP1 line, you revolve this by 2 pi degrees. If you revolve it by 2 pi degrees, you will come back to the initial position so that the coordinates will coincide. So f theta, this is also equal to, so how can I write this revolution? So we start here, then we revolve by 2 pi degrees, so the whole angle will be with respect to x-axis would be the complete rotation theta plus 2 pi, right? So theta, you revolve by theta first, then you revolve by 2 pi, you get the same. Also, if you revolve by 2 pi again, you will get the same ratio theta plus 2 pi, then again 2 pi. So I can go on like this, but instead I can write this as theta plus 2 n pi, where n is an integer. Why I called n an integer? Because you can revolve this in clockwise direction as well. Still you will get the same ratios. So this is what you should know before we go on to defining general solutions of sine, cosine and tangent. So these are also called periodic functions. You will learn about periodic functions in the university when it comes to Fourier series, Fourier transform. Okay, let's go to this. So how to find general solution for sine theta is equal to k. So what does this mean? Sine theta is equal to k. This means find theta such that sine of theta is equal to that ratio. So you asked to find theta. Theta can be any angle, right? Any angle that you can find whose sine ratio or whose sine function is equal to that specific ratio. So how I can tackle this? Under associated angles, you learn that in the first quadrant and second quadrant, sine values can be equal. So any angle in the second quadrant can be represented by an associated acute angle. So I have mentioned this. I have mentioned that in here in this diagram. You can see that sine of theta will have a ratio, certain ratio we don't know yet. We can call it k. So let's call it k, right? So sine theta. So this sine theta can be obtained by sine pi minus theta. We can also call this sine 180 minus theta. Right? So same ratio can be acquired by two different angles. So these angles are different, right? This is sine theta, so this is theta, this is pi minus theta, right? And also this k, as I told you earlier, if you understood this one, the logic behind the periodic functions, every rotation, every complete rotation will take you to the initial position. So now I can make this in general. So sine theta is sine is equal to phi minus theta. Also sine theta, so sine theta is at this position is equal to 2 pi rotation. So sine theta plus 2 pi, and sine pi minus theta. So if you are here, again a complete revolution will leave you at the initial point. So if you consider this one, sine pi minus theta plus 2 pi will also give you the same result. So in general, I can write this as sine theta plus 2n pi. This is also equal to sine pi minus theta plus 2 n, let's say m pi. So what do you get here? Sine theta plus 2n pi sine 2m plus 1 pi minus theta, right? So sine theta. So all these angles, theta plus 2n pi and 2m plus 1 pi minus theta, all these angles will satisfy this equation. All of them will satisfy this equation. So in this way you can find all the theta, all the angles which satisfy this equation. So I will write down the general equation here. So if you are given a question like this, sine theta is equal to k, you have to find all the theta which satisfy this. So first what you do here is, so the first theta that will satisfy this would be the positive angle. So we say that find let's say that k is equal to sine alpha. So theta is the general angle, this is the general angle. Let's say that k is equal to sine alpha. Sine alpha in this case I take it as alpha least, so, smallest positive angle. I'm taking alpha as the smallest positive angle, in this case this. So I'll write this alpha. So I'll make this alpha. So don't worry about these things now. Let's call this alpha, smallest positive alpha. In some books, alpha is taken as least positive angle, or right, or least positive angle. So but you should stick to this definition because it's not confusing. So sine theta, for which angle whose sine is equal to k, for which angle which is the smallest positive angle whose sine value is equal to k. This happens, we'll find an alpha is the smallest positive angle whose sine is equal to k. If this is the case, sine theta is equal to sine alpha, then in general theta, all the theta can be represented by this equation, n pi plus minus n to the power of alpha. So this is the general solution for sine function, general solution for sine function. This theta will represent all the angle, theta general solution. Right? So alpha is called principal solution or trivial. Alpha is called principal or trivial solution because alpha is the first angle whose sine is equal to this ratio. So this ratio can be either positive or negative depending on the problem. You have to find the best angle, suitable angle. So for example, let's say sine theta is equal to half. So what does this mean? You have to absorb the meaning of this. So you are supposed to find an angle, find all the angle whose sine value is equal to half. So first you find the smallest positive angle. So the smallest positive angle. So sine function is positive in the first quadrant and second quadrant. So the smallest positive angle will lie in the first quadrant. So half sine pi by 6 would be equal to half. This is the smallest positive angle. Therefore, the general solution can be written as n pi plus theta n pi plus power of n pi by 6. Instead of alpha, you can write pi by 6. I forgot to mention this, where n is an integer, right? So this is the general equation for sine function. So we'll look at other general equations as well. So I'm just gonna write these down since you are already familiar with the theory behind these general solutions. So let's say cosine theta, cos theta is equal to k. You know that cosine is positive in first quadrant and fourth quadrant. So you can find an angle in the first quadrant and second quadrant which is equal to, whose cosine is equal to k. I assume that k is positive in this case. If k is negative, the cosine would be in the second and third quadrant, right? So in this case also we have to find the smallest positive angle which satisfy cos theta is equal to k. The smallest positive angle, let's say cosine alpha, right? So cos theta, in this case the general solution is written as theta is equal to 2n pi plus or minus alpha. This is general case. N is an element of integers. Right? Okay, how did we arrive at this solution? Let's look at this in depth. So cos theta is equal to k at this position. Also, the same ratio can be obtained by cos minus theta. Cos minus theta. So if we are at this position, this is the plus theta where you get plus here. This is a minus theta where you get minus here. Also, you can obtain the same ratio for any revolution by 2 pi. So if we add plus alpha plus 2 pi revolutions will also give you the same ratio. If we add minus 2 pi plus revolutions also give you the same ratio. As you saw earlier, it doesn't matter whether it is positive revolution or negative revolution. Still, if you revolve by 2 pi anti-clockwise or clockwise, you will obtain the same coordinates, right? So let's do an example. For example, cos theta is equal to minus half, right? In this case, I took k as a negative value. So for which angle whose cosine is equal to minus half? So first you have to find the trivial solutions, which means the smallest positive angle whose cosine is equal to minus half. What is the smallest positive angle? So smallest positive angle would be cosine of pi minus pi minus pi by 3. So this is the smallest positive angle whose cosine is equal to minus half. So when this is case, this is called an alpha. So you can write theta 2n pi plus or minus pi minus pi by 3. We can simplify this 2n pi plus or minus 2 pi by 3. You can either stop here or you can simplify more. You can take 2 pi outside, then you are left with plus or minus 1 pi. Right? So this is the solution for this. Let's look at tan theta. So tan theta is equal to k. This means find angles such that whose tangent is equal to k. So we can find many angles, actually infinite angles, which satisfy this equation. So as you know, the tangent is positive in first and third quadrant. So any ratio, so a tan theta is also equal to tan pi plus theta, right? You saw this in the previous lessons. And also I told you that any revolutions by 2 pi, whether it is anti-clockwise or clockwise, will result you in the same ratio. So in this case, I will write down the general solution. If so tan theta equals k, so I'm going to find the smallest positive angle which satisfies this equation. Let's call it alpha. So we can write it as sine tan alpha. Now we have tan theta equals tan alpha. Then when you obtain this step, you can write the general solution as n pi plus alpha. N pi plus alpha, where n is an integer. Right. Now let's look at this solution as well. So tan theta, right? If alpha is positive, alpha, right? then any n pi means by pi rotation. So if we are here, you can see here that this is a straight line, so this is a straight line, so you obtain this one by rotating by pi, right? Again you can come back to this position if you rotate by pi. So that is what is given in here, right? N pi rotations will take you to the required position. Okay, let's do an example. For example, tan theta is equal to minus 1 over root 3. Right, so we have to find the smallest positive angle, which is equal to minus root 3. The smallest positive angle, so tan theta is negative in second quadrant and fourth quadrant. So the smallest positive means anti-clockwise, so the smallest positive angle would lie in the second quadrant, right? So because it has to rotate through second quadrant to go to the fourth quadrant, so angles in the second quadrants are actually smaller than the angles in the fourth quadrant. So what is the smallest positive that is equal to this? We can write it as pi minus pi by 6, pi minus pi by 6. So tan theta is equal to tan 5 pi by minus 6. So when you are at this position, you can write the general solution as theta n pi plus 5 pi by 6. So we can simplify this more if we take pi out. 6n plus 5 divided by 6. Right, so this is how you find general solutions of trigonometric functions. Okay, we'll stop it here, and we will discuss more examples during the discussion, so make sure you go through this again and again. If you don't understand anything, please refer to me. Okay, thank you.